Alright, today's lecture is over significant figures. What a significant figure is basically, let's just talk about breaking down what significant and figure means. Okay, significant is something significant, that means it's important. A figure, that's a number. Okay, so all we're talking about is important numbers. Numbers that we have taken the time, that we've said, hey, this is important enough that we have measured it. Okay, if you look to the screen behind me, you'll notice there's a ruler. Okay, most rulers go from 25 to 35. Okay, one ruler is just a little bit better than the other one though. Okay, it's got more things to measure with. Okay, so we've got more graduations here. Okay, so these things are going to tell us more precisely where we're at. Okay, both pencils, these are pencils, that's a pencil lead. Okay, both of them are the same size. I'm going to go to the same spot, but one of them we can read really well, and the other one we can read, we can get a guesstimate in there. We can get that degree of uncertainty. We can say, it's somewhere between 25 and 35. It's close to 30, but that's about as close as we can get with it. If we look down at the bottom one, though, we can see, yep, it's past 29, but it's not quite to 30. We can even read as 29.2, and then we can go to other degrees of certainty, and we can say it's 29.25. Okay, so I can read this one much better than I can read the top one. Okay, so my measurement is more significant. Okay, what we're going to figure out, what the rule we use to figure out whether something's significant or not, is the thing called dot right, not left. If you go through your book and you look over significant digits and significant figures, they give you rules, and there's like 8 of them. There's a whole bunch of things that you're going to be confused about. You're more than welcome to go through it and figure it out. I just don't teach it. Okay, there's a lot of kids that get stuck on certain things, so I go with just a little simplified rules here. Okay, so in the dot right, not left, the dot is in reference to the decimal point. If there is a decimal point, I'm going to move to the right. I'm going to show you what I mean by that here in a second. If there's not a decimal point, I'm going to go left. Okay, so I've got some numbers up here. Okay, I just put some random numbers in there. That's just not binary code. So we're going to go through here. On the first number, 10. Okay, does it have a decimal point? Well, no, it doesn't have a decimal point. So if there's not a decimal point, I go. All right, if there's not a decimal point, we're going to go left. All right, so with 10 not having a decimal point, I'm going to move left. So what I'm going to do is I'm going to pretend like I'm an archerer, I don't know how you'd say that. So I'm going to get my bow out, and I'm going to shoot, fire my arrow off. Okay, so I'm shooting my arrow, and I'm going to go left. Okay. Now, when an arrow approaches a 0, it goes right through the middle of that 0. Okay, so it's not going to stick to any zeros. All it's going to do is stick to whole numbers. Okay, so it's going to go right through the 0, and it's going to stick to the 1. Now, anything beyond the 1 is going to be significant. In this case, the only thing that's significant is the 1. Okay, so this particular one has one significant digit. All right, the second one number, 1001. Okay, still no decimal points, so I'm still going to move. I'm still going to move left. So I fire my arrow off. In this case, I hit the 1. So I have an arrow that hits the 1. Everything is protected beyond that. So I have 1, 2, 3, 4 significant digits. Okay. We're going to go to the next one. We have 10,010. Okay, same thing. I'm going to shoot my arrow. Now in this case, though, I'm going to go through that 0. It's going to hit the 1. Count again. So once again, I have 4 significant digits. Okay. The next number I have is 1000.0001. Okay. So now this one I have a decimal place. So I have to come in from the right. Okay. So fire off. I hit the 1. everything behind it is protected, it's significant. So in this case I have 8. Okay, fire off on the second one where I have 1000.0000 and once again 8. Okay, the next one's going to be pretty similar. If you have a question on it, come in and see me about it. I want to go jump down to the bottom ones real quick. Here we have a really small decimal. I'm going to fire through because I'm going right because I have a decimal. I hit the 1, and even though it seems like I'd have a whole bunch of significant numbers there, I only have one significant number. Okay, because I could change that by doing with the metric system, doing those prefixes. Okay, I've measured, but I just measured really small, and that's okay. All right, let's move on to the next page. Again, if you have questions over the other ones. All right, we're going to move on to adding and subtracting of significant digits now. Let's say you guys want to measure something and you want to add them together or subtract them. We're going to work with adding first off. Subtraction is the same, it's just the opposite function. Let's say you want to figure out what the total distance of a row of pencils are for whatever reason. So you have measured the pencil and you find out that the pencil is 10.4 centimeters. Okay, you have a buddy that's measured the same pencil, the same style of pencil, and when he measures it, he's using a different ruler. This is one that measures by decimeters, but he knows that 1 decimeter is 10 centimeters. So what he comes back with is he's going to tell you, nope, it's 10 centimeters. Okay, so when you come and you add them, you're going to add them the same way you would normally add, and what we're going to do is we're going to add those up. So it's 402. So we get a number of 20.4. Okay, that's our just dry calculator answer. This is just saying, hey, if they're exactly those things, that's exactly what our answer would be. But we don't know what that 10 is. We don't know if that 10 is 10.4. We don't know if that 10 is 14.9. We don't know exactly where that 10 is because he measured with a decimeter ruler. Okay, he didn't use a really good ruler. So we have to take it for what it's worth and assume it's somewhere between 14.9 and 5.1. So what we're going to do here is we measure by columns. So when we're adding and subtracting, what we're going to do is we use that column, and we know that we definitely have that ones column, or the 10s column is figured out there. Okay, so we know that that is significant. He knows for sure it's somewhere in that range. Okay, if I round it up or round it down, he knew for sure that it was a 10-ish. Okay, so that's significant. We're going to keep it. So that 20 is there. Now the 0, he has one that is significant because we know it's significant because it has a decimal point in there. It goes to 0.4. Now the other one we're not quite so sure there's no decimal. Okay, so what we have to look at here is that's the last one that was significant. Okay? So my answer is going to be a 2, but the 0 stays. Now the reason the 0 stays is because if I took the 0 away, you would end up with a number of 2. If you came to mow my lawn and I told you I was going to pay you $20 and I paid you $2, you'd probably be a little upset. We have to have things that are placeholders, and a 0 is a placeholder in this case. Okay, then I'm going to throw the unit down right there. Okay, so my answer is 20 centimeters. There's no decimal point, nothing other than that on that one. And we'll see more of that in the measurement lab. Okay, now on the multiplying and dividing, it's so much more easy. Okay, all we're going to do is we're going to take whatever the lowest measurement was, and if the lowest measurement had 2 sig figs, your answer will have 2 sig figs. So let's throw something out here. Let's say that you're going to do, you need to figure out what the perimeter is of something, or the area is of something. So let's say that this side is 4.0, and this top one is 120 That's a little bit big. Let's say it's 12.3. Okay, that sounds better. Now, if I have 4.0 and I have 12.3, we have different numbers of significant digits. 12.3, if we did that and we did the arrows, we would see it has 3 sig figs. 4.0 has 2 sig figs. Okay, so if I need to take the 12.3 times 4.0, what I find out on that is I end up with an area of 49.20, and let's say these are meters, and that would be meters squared. All right, now we talked about what is significant and what is not. The 2 is the lowest one. Okay, I can't be more precise than the 2 sig figs. So I have to come up here and I have to see 49.20. I only have 2 sig figs. Which ones are significant? The 4 and the 9. Okay, so everything else is going to get cut off because we can't measure that well. Okay, so it's just a measurement thing. Everything that's going to come off on a significant digit is going to come off of the end. Put a label on it, and we are good to go.